Hi everyone, and welcome to the channel. Today we are starting a new lesson on electricity, one of the most important and fascinating forces in the world. And I assure you that by the end of this lesson or video, you'll be able to define what electricity is and what causes it. You'll also be able to identify both positive and negative charges. And finally, you'll be able to understand and explain what static electricity is in details. All right. Brethren, if you haven't learned the basics of electricity, I will encourage you to pay much attention to this particular basic or foundational studies because it's going to help you in the later series or parts that we'll be discussing. All right, let's get started. Stay tuned. Friends, electricity is all around us. It's everywhere in our lives. It powers our homes, our devices, and even transportation. So we see that everywhere we are, electricity is there with us. But what exactly is electricity? And this is the question we need to ask. Today we will start from the very basic. And by the end of this lesson, you will learn and understand what electricity is. You will know how the charges work, and you'll be able to explain in details what static electricity is about. Because this knowledge is the foundation for understanding later topics in circuits, magnets, motors, and even generators. So pay attention, take your pen and your books, and let's dive in right away. All right, what then is electricity? Now we are saying that electricity is a form of energy. This is very, very important because we have different types of energy. In grade 5, we learn about energy as the ability to do work or cause changes. So we understand that electricity is a form of energy resulting from movement. Movement is one key, and then presence of electric charges. So electricity is a form of energy. We have also learned in grade 5 the various or some forms of what energy. So electricity is one form of what energy that we are looking at today. And we are saying that electricity is a form of energy resulting from movement or presence of an electric charges. And we have two types of charges that we'll be talking about today. That is the positive and the negative charges. The positive and the negative charges. Friends, we have learned something called an atom, or we have something we call atom. Atom is the smallest basic unit of matter. Okay? The minute, the tiniest particle of matter is called an atom. And an atom has a structure. And in this structure, it has some particles or charges in there. In an atom, we have something we call protons. We have protons. We have electrons. We have electrons. And then we have, sorry, that is R. Oh my goodness. Then we have what we call neutrons. Neutrons. So neutron is spelled N-E-U-T-R-O-N. Sorry, that is O. We have N. So we have protons, electrons, and neutrons in an atom. So atom is more or less like a circle in a circular shape. That is how the structure is. And then we have the P, then we have the E, then we have the N. So an acronym here, PEN or NEP. So in this atom, we have protons, electrons, and neutrons. And protons has positive charge. Electrons has negative charge. This is the charge of an electron, negative. And the neutrons, it is negligible or neutrally charged. Okay, so these two charges, protons and electrons, that is what we are coming to talk about. These are the two types of charges we are coming to talk about. So when an electron, which is negatively charged, this one, when an electron move, they create what we call current electricity. That will be in part 1b. So we'll be talking about current electricity in part 1b and how they flow. So in part 1a, we are only talking about static electricity. So here we are saying that when an electron, which is negatively charged, when it moves, it creates current electricity. Now, when the electrons build up in one place, when these electrons, when they move freely, they have a channel, okay? Maybe they have a pipe or a tube or a pathway. When they are able to move freely without any obstacle, we say they are forming what? Current electricity, without any break. But assuming that the pathway is like this, and it has been blocked here, you know that they cannot flow through. So it will what? There will be a breakage here. So this, as a result of these electrons not able to move, they tend to build up. Now, as a result of building up, they form what we call static electricity. So you see that electricity, the current is flowing, but it is blocking up. So there is something, there is an obstacle on the way. And as a result of this obstacle, you see that the electrons will now be building up. You'll be building up, building up, building up, building up, building up. So as a result, we are saying that they are forming what we call static electricity. Meaning that the current is coming, but it is not moving up. All right. And for a current, this is the key rule I want you to take note of. Now, for the current, there are two things that happens. When you take a magnet or a battery, so we have a battery here on top. We have another end here. So a battery has both positive and negative terminal. So we are saying that when we have a positive terminal meeting another positive terminal, they repel. They will never attract. So a positive terminal, which is plus, so let's write plus here, and then another plus here, they will repel. But let's write negative here, and then another negative here, meaning we have negative terminal here. This is a battery, okay? This is an illustration of a battery that I'm doing, I'm putting down here for you to understand the lesson clearly. So now, when this opposite, this is the key rule I want you to understand. This opposite part of a battery terminal, if it comes close to the positive part, they will repel, meaning they will push each other away. They will never connect. But the moment you have another battery, this is positive, and then another battery, and this is negative, immediately you bring them together, they will connect or they will attract. So the rule is that opposite charges, they attract, meaning positive and negative charges, attract each other. But like charges, like positive and positive, negative and negative, they repel each other. That is why you see here we have opposite charges what attract, whilst negative charges what repel. So this is the concept of electricity we are talking about. And remember that in this lesson we are only going to focus on static electricity. All right, so let's move on to look at what static electricity is all about. So we are saying that when a pathway, when there is a pathway where electric current is supposed to flow through and there is a blockage, the current cannot penetrate, hence it remains stagnant or static. So you can see that example as what a dam or a river which is flowing, and accidentally there is a blockade. What happens is that the water can no longer flow but remains at a particular surface or place. So these rules explain what we've learned earlier, explain why some objects do stick to each other and others do push each other apart or repel. So now static electricity is this: the current cannot flow through, but it is generating. Electrons are moving. Okay, the negatively charged particle is moving, but it cannot flow because there is an obstacle here that is blocking the current. So the current now becomes what? Excuse me. The current now becomes static. All right. So we are saying that static electricity is the one that stays in one place. It's caused by buildup of what? Charges. This is a key thing for you to understand, that we learn about positive and negative charges. So if any of these build up as a result of an obstacle or blockade, it becomes what? Static electricity. Now, how does it happen? When electrons transfer between objects without a complete what? Pathway. So electrons, they are negatively charged. So when they are able to move between two or more objects that do not have a complete pathway. Okay? So the current is being generated, but it doesn't have a complete pathway to pass through. So it doesn't have a parallel pathway or pathway that will allow the current to flow through without any obstacle. So you see, so that is what causes what? Static electricity. So we are saying that it occurs when electrons are transferred from one object to another, but they do not flow continuously. The charges build up on the object surface. So the first example I want us to look at is, imagine rubbing a balloon on your hair. Okay? Sorry. Imagine what? Wrapping a balloon on your hair. So this is human hair. And then we have a balloon. Okay, that has been inflated. So when you wrap this balloon on a hair, what happens is that the hair will lose or will give out electrons to the balloon. So electrons have been given up, negatively charged. This is negative charge. So electrons have been given up to the balloon. Now remember, when electrons are lost here from the hair, the balloon will receive the electrons, which is negatively charged, but the hair becomes positively charged. So the hair now gave out its electrons to the balloon. So now the hair becomes positively charged. So later you realize that the balloon will be stuck or will stuck to the hair as a result of positive and negative charges coming in contact. So we say that your hair will lose what? Electrons and become what we call positively charged. So the hair here is positively charged, whilst the balloon is what? Negatively charged. And these two, so the positive hair will now get attracted to the negative what? Balloon. I believe this is clear. All right. Another one is, when you use comb to brush your hair. So when you are brushing your hair or combing your hair, we realize that electrons have been lost from the hair to the comb. So the comb now receives what? A negative or electrons. And the hair still remains positive charge. So now this comb, when you use it to try to pick either a paper or anything that is light, you will see that it will have the tendency of attracting to the comb because electrons have been transferred, but there is no pathway for that electrons to pass through. That is why it is called static electrons. So these examples are a clear indication that there is an electricity production, but it does not have a pathway to pass through. Sometimes this is another valid examples that I want us to consider. In the home, when you wear socks and then you walk on a carpet, you realize that there is a friction between the socks and the carpet. So the body becomes, let me say, charged. Okay, your body becomes charged as a result of the friction between your socks and the carpet. Electrons have been transferred, so your body becomes what? Negatively charged with that electrons. And if you touch any doorknob, metallic specifically, any metallic doorknob is sometimes what? Jam and cause a small spark. This happens. If you haven't experienced that before, you can say that in the comments. If you have experienced that before, you can tell me that in the comment section. And another thing I want you to understand is that one natural way that we normally see static electricity or static electricity is through lightning. Okay? Lightning. The lightning that happens all the time. This is as a result of what? Static charges in the clouds that jump into the ground or to the ground. Lightning that we see when it's about to rain is a typical example of what? Static electricity, because it's a huge static charges that are in the clouds because they have built up and accumulated. So as a result, they tend to jump to the ground, and that is what we see. So brethren, static electricity is stationary, waiting to move, and is basically caused by friction or separation of what? Charges. So today's lesson has been most informative, and I believe that you have learned something great. And then if you enjoyed this lesson, like, subscribe to the channel, and turn on the notification bell so that you don't miss the part 1B of this particular lesson, which I'll be taking you through on current electricity and why it flows. So if you have really enjoyed it, please give me comments in a session or in a comment section, and then make sure that if you have experienced any of static electricity in your homes or wherever, practice it, and then you see the result we are talking about in this chapter. God bless you. Stay tuned until we meet in the second or in our subsequent videos. Bye-bye.